Welcome back to Wong Chemistry channel. This is the part 3 video of your 7.1 acid and base. In this video, we are going to just talk about strong acid and strong base. We are going to look at what is actually strong acid and strong base. And the most important thing in this video is we are going to calculate the pH value for the strong acid and the pH value for the strong base. Okay? Knowing that your strong acid, the pH value will definitely be less than 7. And also for the strong base, the pH value will definitely be more than 7. So we are going to calculate the pH value for both of the strong acid and strong base. Before calculating the pH value, let's take a quick look on what is actually strong acid and strong base. Both of the strong acid and strong base will dissociate completely in an aqueous solution. The word dissociate completely over here, it also means that it will break completely. So if you are having your acid in the water, the acid will break completely. It will dissociate completely, ionize completely. Okay? Your strong base also the same. It will ionize completely when you place your base into an aqueous solution. That will then result in the degree of dissociation equals to 1 or the percentage of dissociation equals to 100%. Everything that you have at the beginning will dissociated. Your strong acid will be 100% dissociated. Your strong base will be 100% dissociated. Let's take a quick look by using equation. So this is my strong acid. My HNO3 is my strong acid. So let's say I started the dissociation, I started the reaction initially with 100% of my strong acid. So initially, there will be no product form. Agree? But at the end of the reaction, at final, my strong acid will be 0. Why my strong acid will be 0? Because it will dissociate completely. So everything that the strong acid have will then become the product. I will then have 100% of the H plus and 100% of the NO3 minus. So the one that I want you to pay attention is the HNO3 will dissociate completely and form 100% of it. Can you see that? Okay? Simple. And that is what we mean by completely dissociate. It will break 100% and the final will become 0. Okay? Next, how about this strong base? I have a barium hydroxide, which is a strong base over here. So as always, I started the base, let's say, with 1 molar. It's a concentration, so I start with a 1 molar. When I start with 1 molar, my product will be 0. There will be no reaction. Okay? Nothing is formed yet. But when I reach the final, my strong base will become 0. Because it will be completely dissociated. When it completely dissociated, I will form 1 mole of my barium 2 plus and I will form 2 mole of my OH minus. So the question is, why 2 mole? Why not 1 mole? Bear that in mind, in 1 BaOH2, in 1 mole of barium hydroxide, I will produce 2 mole of OH minus ion. So 1 to 2 ratio. So if I have 1 molar of the barium hydroxide, I will then form 2 mole of the hydroxide ion. So there are 2 things I want to show you on this. First, the initial and the final. Since they are going to dissociate completely, the final must be 0 for your reactant because there will be completely reacted, completely dissociated, completely break down, completely ionized. Okay? So all your reactant will then turn into your product. So the second thing that I want you to look at is the ratio. The ratio of your H plus and your OH minus. How many H plus is produced by your strong acid? How many OH minus is produced by your strong base? Because that will determine the pH value. Okay? So be extremely careful with the balance equation. Make sure when you write the equation is balanced. Alright? So here is a list of examples for the strong acid and strong base that you can use it as a reference. And obviously in the acid, you can see that we are producing all the H over here. And can you see that? You're producing your 2H+, your diprotic strong acid. And in the base, obviously, is the OH that you have. And can you see that you're forming your 2-hydroxide ion? Alright? And I want to remind you, this is only an example of the strong acid and strong base. We have a lot more different strong acid and strong base. Okay, this is among the strong acid and strong base. So next question, let's look at how do we calculate the pH of a strong acid. There are a few steps. The step 1 is you are going to write a balanced chemical equation for the acid dissociation. So if you're having an acid, your HX, let's say, when you write the equation, make sure your equation is balanced. Okay, you are not only breaking it down, you must also balance your equation. Alright? The second step is you must compare the ratio of the acid and also the H+. Why we are comparing it to the H+? Because it's an acid. So the H+ will definitely be produced. And in this second step, we actually want to identify the concentration of the H+ that we produce in the strong acid. While in the step 3, we can calculate the pH value. So when you have the concentration of the H+ already, you can put into the formula of the pH equals to negative log H+. And then you will be able to calculate the pH of your acid. And kind reminder, since it's an acid, therefore the pH value calculated must be less than 7. Bear that in mind, if you are calculating the pH of an acid, the pH must be less than 7. It's a common sense over here. Alright? Let's try the first example on calculating a strong acid pH value. So the question asking for the pH of a 0.33 molar of your HNO3. Knowing that the step 1 is to write the equation of your HNO3 dissociated. So I have my HNO3, definitely in aqueous, will be completely dissociated, so it's a single-headed arrow, your irreversible reaction, forming your H plus aqueous, and also your NO3 minus aqueous. And before you move on, make sure they are balanced. HNO3 forming 1 H plus and 1 NO3 minus. Okay? I started off with the concentration initial of the HNO3 is 0.33, knowing that this will be 0. And knowing that the final at the end of the day, your acid will be 0. So your product of the H plus is a 1:1 ratio. So I will then produce 0.33 molar of my H plus. And from that, we realize that the concentration of H plus in this question is 0.33 molar. Okay? And from that, we can calculate the pH value. Why pH value straight away? Because the one that we have is a H plus. Therefore, we can calculate pH equals to negative log concentration of the H plus. Okay? Substitute in the value where we are going to negative log 0.33. Press your calculator correctly. You realize that the pH value calculated is 0.48 over here. Okay? And as we agreed, since we know that this is an acid, we already predict the pH value must be less than 7. And obviously, the pH value calculated over here is less than 7. So, your H3O plus is an acid. Correctly. Okay? So, this is the pH value of this question for your HNO3. Simple. Another example that you have is the pH value. We are still looking for the pH value of 0.42 molar of H2SO4. Knowing that your H2SO4 is an acid, therefore the pH value that we are predicting over here must be less than 7. The moment you calculate the pH value, you know that the answer must be less than 7. And for this question, as always, the step 1 will definitely the chemical equation of the dissociation of H2SO4. So H2SO4 aqueous is a strong acid. Therefore, single-headed arrow, irreversible reaction. dissociated into H plus and also SO4 2 minus. Bear that in mind, everything will be in aqueous. And you shall not move on yet because your equation is not balanced. Make sure your equation is balanced by looking at the H plus. Can you see that? So right now, you need 2 H plus to balance your chemical equation. So right now, can you see the trick of this question? I started off with the initial is 0.42 molar of my H2SO4, knowing that the initial over here will finish. So the final over here will be 0. Okay? While for your H plus, your initial will be 0, but all of your acid will then become my H plus. But the ratio is 1 to 2. Therefore, it will be 2 times of the 0.42 molar. Okay? And from there, you realize that the concentration of H plus calculated in this question will be 0.84 molar. Since the concentration that we have is a H plus, therefore, we can calculate the pH value straight away. pH equals to negative log concentration H plus. Substitute in the value negative log of 0.84 and pick up your calculator and press your calculator correctly. Make sure you put in the negative log in front. And when you press your calculator, you realize that the pH value calculated for this question is 0.076. That is the pH value calculated, and it's correct because it's less than 7, and it should be less than 7 because your sulfuric acid is an acid. And in this part of question, just be very careful with the concentration of H plus and also the concentration of the acid originally. Because it's a diprotic acid, therefore you will be forming 2 mole of H plus. Therefore, the concentration shall times 2. Okay? That is the trick. Simple. Next, let's move on to the pH of a strong base. Look at the trick of my slide. I'm asking for the pH of the strong base, knowing that the pH of the strong base must be more than 7. Agree? Okay, and we also know that in the base, we only have OH minus as a dominant. So, how do I calculate the pH value of a strong base? Extra 1 step. The step 1 will be still the same. Write and balance the chemical equation of the base dissociation. So, we are going to dissociate your strong base. In the step 2, will still be the same, very similar, but we are going to compare the ratio of the base to the OH minus. Because it's a base, therefore, it will produce OH minus. From the OH minus, we need to identify one thing in this step. The concentration of the OH minus. Okay? And since in the second step, we are getting the concentration of OH minus, therefore, in the third step, you can only calculate the pOH first. From the concentration of OH minus, you will only able to calculate the pOH using the formula of pOH equals to negative log OH minus concentration. But the question asking for pH, how do I calculate the pH of a strong base? Simple. You are going to use the formula of pOH plus pH equals to 14. That means the pH value of a base can be calculated by using 14 minus the pOH above. Alright? And bear that in mind, the pH value that you calculate over here must be more than 7 because it's a base. So can you see the difference over here? Since it's a base, we are producing OH minus. Therefore, we will only have the concentration of OH minus. That is the reason why we must start off with calculating the pOH in the base. Then only we convert to the pH by using the relationship between pOH and pH equals to 14. Alright? Simple? It's very easy. Just be very careful. You need to remember in the base, OH minus is the dominant. Okay? So let's try an example over here to calculate the pH of a 0.25 molar of KOH. Guys, we know that KOH is a base, right? And we know that base will produce OH minus. Therefore, we can only calculate the pOH first, then only we calculate the pH. Remember that? And since it's a base, pH will definitely be more than 7. Okay? First and foremost, the equation, the dissociation of your KOH. KOH in aqueous will dissociate completely, alright, to form your K plus aqueous and also your OH minus aqueous. Next, make sure your equation is balanced. 1 mole of K, so you're forming 1 K plus. 1 OH minus, so you're forming 1 OH minus. Okay? Knowing that the concentration initial of the KOH starting off with 0.25 molar. Okay? While the concentration initial of your OH minus is 0. There's no product formed yet at the initial. And in the final, alright, at the end of the dissociation, your KOH will be 0 because everything will be completely dissociated into your OH minus. It's a 1-to-1 ratio. When it's a 1-to-1 ratio, it will then be 0.25 molar of your OH minus. From that, we know that the concentration of the OH minus in here is 0.25 molar. Okay? And guys, it's a OH minus. So my question, can I use the formula of pH equals to negative log H plus? Can we use this formula? We cannot use this formula because we don't have the concentration of H plus. Can you see that right now? And the only formula that we can use is your pOH due to the concentration of OH minus. pOH equals to negative log concentration of OH minus. This is the formula that we can use right now. Okay? Substitute in the value, your pOH equals to negative log 0.25. Press your calculator very correctly. Make sure you press the negative log as well. And when you press your calculator correctly, you will be able to get 0.60. And bear that in mind, 0.60 is only the pOH. The question asking for the pH value. So how can I find the pH value? Very simple. pH will then be equals to 14 minus pOH. So you will have your 14 from the relationship minus the pOH calculated 0.6. Therefore, your pH value calculated is 13.40. And that is the pH value. And as we agree, the pH value right now is more than 7. Okay? Because it's a base. Simple, very easy. That means in the base, we need extra 1 step to find the pH value. Okay? Because we will be able to get the pOH first. Then only we find the pH value. Alright? Next, and also the last example for this video, a very similar thing is the question still asking for the pH of a 0.17 molar of your calcium hydroxide. Okay? So the same story. It's a base. Therefore, the pH calculated must be more than 7. But since it's a base, guys, we only have OH minus. Therefore, we can only calculate the pOH first. Then only we calculate the pH value. Okay? Starting off with the dissociation of your strong base, you have your calcium hydroxide over here in aqueous. Dissociate completely to form your Ca2 plus aqueous and also your OH minus aqueous. Alright? And as always, double, triple check your equation. Make sure it's balanced. Calcium, 1 mole. Calcium, 1 mole. OH is a 2 over here. Therefore, your OH minus will be produced 2 mole. Can you see that? So make sure your equation is balanced before you proceed to any of your calculation. So starting off with the concentration initial of your calcium hydroxide is 0.17 molar. Okay? The initial of OH minus is 0 molar because nothing is produced yet. And at the final over here, your reactant will finish. So when your reactant finish, that means everything will be converted to your OH minus. But can you see the 2 mole? It's a 2 mole over here, 1 to 2 ratio. That's why it will become 2 times 0.17 molar. Okay? And from that, we then able to calculate the concentration of OH minus. Concentration of OH minus will be 2 times 0.17 molar. That will equals to 0.34 molar. Okay? And since it's a OH minus, therefore, we'll be calculating the pOH first. pOH equals to negative log of the concentration OH minus. Substitute in the value correctly. Make sure you have times 2 because of the 2 mole of OH minus. Then you will have your 0.34 over here. Press your calculator very correctly. You will be able to get the pOH is 0.47. And bear that in mind, 0.47 is the pOH. Question asking for the pH. So what do we do to find the pH? Very simple thing. Okay, just a very similar thing. There is only one method to find the pH from a base. pH equals to 14 minus pOH. Very simple. 14 minus 0.47. Okay, therefore the pH calculated is 13.53. And as we agree, your pH calculated right now is more than 7 because it's a base. Can you see that? Very simple. Okay, and that's it about this video on strong acid and strong base, and also on calculating pH value of the strong acid and strong base. Just be very careful with the number of mole of OH minus or the H plus that you produce in your base and in your acid. Okay, make sure your equation is balanced. And make sure you know how to use this formula correctly and also the formula of your pH. Bear that in mind, this pH formula can only be used when you have the concentration of H+, okay? And to find the pH of a base, the base must be able to get the OH minus and the pOH first. Then only we calculate the pH of a base, okay? Simple. If you have any question regarding this strong acid and strong base, drop it in the comment below and I'll get back to you as soon as I can. Thank you for watching and make sure you have liked the video and subscribe to my channel. I'll see you again in the next video.
TunePocket.com